All right, I've opened up Cura, and Cura is made by Ultimaker, which is a brand of 3D printer, and they've created this open source software that's free to download. You can download it on your own computer. It's not very big, and it's free. And it's designed to run with their 3D printers, but they've very graciously made it available to the overall community, so you can choose other brands like the Monoprice Mini, and you can go to select that by popping down this little drop menu here and select, say, Add Printer, and then find your brand. And then it's going to say, well, what material are you using? There's a lot of different styles of materials. We're just going to stick with PLA. That's almost certainly what's in the printer when you go to print this. So you can just leave that generic PLA, the Monoprice Mini. And the nice thing is you get this kind of like sort of preview here of your print floor here. So whichever brand you select, you're going to see a different little printing box. So this little blue box is the volume that we can print on this. And the little grid down the bottom is the print bed. And it's very small with a Mini because the Mini is a Mini. So this is all set up and ready to go. Now to navigate around the spaces, which you don't really need to do too much navigating, but to do that, hold the middle mouse button, your scroll wheel button down to pan around the scene. Hold your right mouse button down to orbit around your scene, and then the left mouse button is just going to select things. Now, you're not really going to do much modeling in this space here. All you're doing is preparing this ready to go. You might make a couple of copies in here, or you might add some infill or whatever, but this is not a modeling software. This is just the software that writes the G code. It's called G code. It's the little language that the printer needs to read in order to print your thing. So in order to get that onto your screen here, I'm going to go up here to the little file menu, pop that open, and we called it table tutorial there. So I'm going to open up table tutorial there, and there it is. And the little table model has dropped onto the scene just like we had it in Vectorworks. It's upside down on the floor, ready to go. So really, we don't actually have to do anything for this. If all you're doing is printing something small, if you want to learn what all these things mean, I'll show you a couple of them really quickly, but you don't need to. I think I'm actually even in the advanced settings here. You can have this in like simplified, and it's simpler. But all these settings do different stuff. But when you're first getting started on this, don't mess with these. Just kind of go with the default settings. You can learn what each one of these things do slowly and have your prints do different things. But the only time you really need to mess with much of this is if you're trying to print a part that actually has to be stressed in some way. You're printing a little tool or a hinge or something, For what we're doing, for just printing something from a model, all it's got to do is kind of hold up its own weight, But there's a couple of little pitfalls to be aware of. Make sure that the print filament size here, and it should be here by default, but if somebody's changed it or something weird is going on, you want to make sure that this 0.175 millimeter, that's the filament that the Monoprice takes. If this is a different number, it could be 0.2, or there's other kinds of diameters of filament. If it's thinking that it's got a different size filament coming out of it, your print is going to be really weird. It's going to be real wispy and thin and kind of looks like it's sort of basket weavy, it'll have this kind of strange, loose, not solid filled object because it thinks it's squirting out more filament than it actually is, or vice versa. So you want to make sure that it's all the things match what your printer is going to do. So this is the number that you want to see here if you're printing onto the Mini. Now the infill, that's what this 25% is. That's this guy down over here. You can see they have these nice little icons that kind of connect, tell you what that number is. You can recognize the icon. Infill density just means once it's printed the outer shell, the kind of the box around the shape, well, what's it putting on the inside? So the only place in this guy, it's so little, there might be a tiny little bit of infill kind of going down the center of this pole here and maybe a little bit inside the feet, but they're so small in most cases. You're printing a little chair or something like that, there's going to be no infill. This number doesn't really matter because by the time it gets the basic outline of it, there's no room for infill. But if you're just printing, say, a sofa or something, maybe it'll be bulky enough. There'll be enough hollow inside to have some infill. Just leave it at 25%. You could probably even get away with like none because these parts aren't, you could take it in your hands and crush it if you wanted to, but you could do the same thing with foam core or little bits of paper that you glued together. It doesn't need to be strong. It just has to be the shape that it is to go into your model. So don't worry about infill. This is really important if you're making parts for stuff, but it doesn't really matter for what we're doing. And the same thing in terms of the material. That's just the temperatures that it's expecting to be printed at and how fast the head is going to be moving, all that kind of stuff. All this stuff, you can really ignore it. I recommend if you want to do more of this and you're interested in this, there's a million tutorials online that you can watch specifically for the Mini or how to use Cura, things that I'll go through and talk about what each one of these things mean and various people's experience with them. But for what we're doing, we don't actually have to mess with any of these. all we need to do is hit slice. So when we click on slice, if you have an SD card already in the computer, you'll notice that the option here is to save to removable. So we can just click right on that and say save to removable, and it'll save it right to your SD card. You don't need to save it to your desktop and then drag it over to your SD card. Now, if you forget to put your SD card in first, you're just going to have to save it wherever you want it. I'm going to click on the little preview button here just for a second so you can actually see what it's doing. There are a couple of things that are going to show up in here, and one of them is going to be this little skirt here. Where's that little skirt? Supports. So generate support. That's that little checkbox that I was talking about. I really recommend don't check this box here unless it's a much bigger object and you don't really care about it. But what this is doing right now, you can see this little ring appeared on here. What that's talking about is this little build plate adhesion, and that's a skirt. And there are different sizes, brim and raft and whatever. For what we're doing, skirt is perfectly fine because that's this little ring that it added. All that's doing is kind of giving the printer a chance to kind of warm up a little bit. There's no way that, I mean, it's just printing the circle straight onto the bed of the printer. It's not going to slide around. But if you had something that was like, say you were printing like a ladder or something, and you just had like 3 tiny little feet that were 4 little feet that were touching the build plate here, and it would be really easy for that to get knocked over or blow over or whatever. If your part moves or falls over in the middle of printing, the printer's just going to keep on happily going along, dropping filament in midair, and you're going to have a twisted mess of filament when you come back to check on your print. This way, the skirt here, or the brim or some of the other ones, are ways to get parts stuck to the bed of your printer. But in this case, because we're doing this upside down table here, that's not a problem at all. This is going to be super easy for this to stick to the floor of the printer because it's this large surface area. But this can be important. So you could go to brim, for example. So if I were to do brim, and then we'll click the slice again here, you'll see it come up with a difference. So now what it's actually done is see how it's tucked the extra bits onto the object, and that would make it super not easy to slide around, but then we have to come in here and cut this all off, and that would be a real pain. So I don't want to do brim. I'm going to go back, and then raft makes a big heavy thing that it sits on like a raft. You never need to do that unless you're doing like, a little Eiffel Tower model or something, and you really don't want it to be sliding around because it would ruin your print. You're printing something for 8 hours and it falls over halfway through. That's kind of a disaster. There's also this little slider down here at the bottom. So you take this guy, you can see it's doing a little animation of what the print head is going to do. So you can slide this around and see like how it's printing in various parts of the slicing process. So that's just kind of like, it can help you visualize what's happening, and it's not terribly important to do that, but you can even click on the little animation on the new version of it and just sort of watch it do its little thing here, give a little preview. And that's only more important if you're doing much more complicated models where the way the print head moves around as it's printing might cause you problems. Again, way more than we need to worry about for what we're doing. So we can just save this to our removable drive, just give it a name that makes sense. It's given it the name that I gave it in Vectorworks, Tables Tutorial, G-code, and it's just saved it right to my SD file. So I can eject it from right here, and the next step we'll switch over to a camera, and I'll show you how this actually gets printed out